In today's class, we will be continuing what we discussed in the last class regarding the physical design of IoT. So we started discussing about the physical design, means the hardware and network protocol design that we do in IoT. So we discussed about the hardware components starting from sensors in the last class. So today we will be discussing about the hardware controller boards mainly. So anyway, I would like to recap a little bit about what we discussed in the interactive class in the last session. So we discussed about the ultrasonic sensor, how it works, its operation, and also we discussed about how we can use it in ESP32. So basically, we uh, also discussed about how we can make the distance measurement and measure the errors in the distance measurements that we can make using the ultrasonic sensor. So basically today we will be proceeding towards the hardware controller boards. So we will do that. So okay, so when we talk about microcontroller boards, we have multiple microcontroller boards that are available in the market for IoT applications. So when we talk about the main features of microcontroller hardware boards, all of them have power supply, a way to give power supply to the embedded microcontroller system. Then we have communication modules installed in it. So therefore we can actually communicate and connect our embedded system, our that microcontroller board, to a certain access point. And then we have the processing unit. So the processing unit can collect, do processing on the data that is collected from the sensors. Also, we can store our data in a selected location in the microcontroller. So we have defined space to store the data in the microcontroller. And we have also input and output pins that enable us to take different types of signals from the sensors. And from the input pins, we can get the input signals, and we can give output signals. So different types of input signals can be enabled into these hardware controller boards, and we can also generate output signals such as PWM signals from our microcontroller board. So as inputs, we can give analog signals or continuous signals, right? We can give analog or continuous signals or digital signals into the board. So analog, digital, or discrete signals we can provide as input signals to the hardware board. As output signals, we can obtain PWM signals by generating that PWM signal inside the microcontroller. So basically we have therefore power supply, communication units, processing unit, storage unit, input output pins uh, in a general microcontroller. So they can be considered as the kind of, I mean, main features that, or main components that we can observe in a hardware controller board. And there are many like popular like hardware controller boards available in the market, such as Arduino Uno, Node MCU, Raspberry Pi, ESP32, and so on. So currently in Sri Lanka, actually, I believe like ESP32, Node MCU, those are very popular because they are low in cost. So because of the uh, inexpensiveness and the features available in these hardware controller boards, I mean features that uh, that that are really essential for us, such as Wi-Fi connectivity, Bluetooth connectivity. Um, those features are available in these ESP32 Node MCU unit boards. So since we can connect to the internet and get a lot of work done, we can consider that these boards are really, important and very useful when we are working with IoT systems. So they might not have like large storage and large or high processing capabilities, but although such drawbacks are there, we are still able to get some like considerable work done from these ESP32 and Node MCU unit boards when we compare with the Raspberry Pi and Arduino Uno boards. So when we consider about the Arduino Uno Raspberry Pi boards, they are also very highly sought out hardware boards where they are able to do like many activities using the available libraries and the resources. So Arduino Uno board is one of the most popular boards that we all have heard about when we talk about IoT projects or when we talk about electronic projects. So we all have, I mean, heard and we like to work with Arduino Uno or Arduino IDE mainly because of its user friendliness and the amount of libraries that enable us to do any sort of a task in an easy manner. When we talk about the Raspberry Pi has more processing ability so that it has the ability to even run like, artificial intelligence. I mean, and related, such kind of algorithms, algorithms related to maybe like neural networks and artificial intelligence algorithms, machine learning algorithms in the Raspberry Pi because it has the ability to store large amounts of data and also, I mean, process large amounts of data with a considerable efficiency in the board itself. So we'll be talking about these Raspberry Pi, Arduino Uno, Node MCU, ESP32 boards in the later instance. So basically, however, Raspberry Pi is kind of costly, and therefore it's not accessible to most of the people who have some, who are not able to deploy this Raspberry Pi in a massive scale in a certain project. Like when we talk about IoT, we have a network of IoT devices, and in each of these IoT devices we need to have certain embedded microcontroller that is able to collect the data and do the necessary processing and transmit that data to the nearest access point or the destination. So in order for us to deploy a massive IoT network, we need to have IoT devices which are less costly and easy to deploy. So if the cost of these sensor-based embedded systems are high, it's hard to deploy it in the practical world. However, like it is good for testing purposes. However, when deploying this network, sometimes we might face challenges due to their unavailability and the cost of the product and so on. So anyway, each of these boards have different features on their own. Let's talk about some of the most popular boards. So when we talk about the Arduino Uno board first, Arduino is one of the most popular hardware controller boards on offer in the market. It is popular mainly due to its beginner-friendly features and the accessibility to the users with a little or no programming knowledge. So like a user with little programming or I mean with little programming knowledge, they can use Arduino IDE easily by following the already available sample codes and adjusting those sample codes according to their needs. The Arduino IDE is mainly based on C++. Its microcontroller module is at Mega 328P and its clock speed is 16 megahertz, right? And so the clock speed is the parameter that determines the processing speed uh, of the microcontroller. So when we take synchronous serial communications, the clock speed determines the rate at which the data is processed. And so the Arduino Uno board has 16 megahertz of data rate. 16 megahertz of clock speed, and therefore it has data rates of up to like 8 to 16 megabits per second. And then when we talk about the advantages of Arduino IDE, as I said before, it is a very user-friendly board that is easily implementable, and we can quickly connect it to a certain IDE, Arduino IDE, where we can develop the code that we can store in the hardware controller board, right? We have Arduino IDE that comes with this uh, Arduino, Arduino setup. We can download the Arduino IDE from the internet, and we can directly install it into the hardware controller board, and we can run our Arduino codes in the hardware controller board. So we can easily, install the software. We can do the coding easily. Also, it supports both analog and digital inputs. We can give analog inputs and digital inputs both. So inside the controller board, we have the ADC, or the analog to digital converter. So from that analog to digital converter, you can convert the analog signals into digital form. So therefore you can work with analog signals also in Arduino. So we have inbuilt analog to digital converter the inside the controller board. This enables us to work with the analog inputs and both the analog and digital inputs. Then we have also some disadvantages. Basically, we have limited memory storage. So when we're talking about the memory storage, we have a flash memory of 32 kilobytes. So 32 kilobytes, and the flash memory is actually the memory that you can keep the memory that you can keep intact even after the power supply goes out, or we don't give any power supply to the hardware controller unit. So the memory that keeps intact uh, even after the power supply is taken. Did you hear what I said? I think I lost connection. The flash memory is the memory that keeps intact even when there's no power supply provided to the unit. So during that time, the memory that stays inside uh, is the flash memory, and it is having a capacity of 32 kilobytes. So kilobytes range is not that large, and therefore we cannot store large amounts of data in the Arduino Uno board. So when we talk about the random access memory or the RAM, even for that it is about 2 kilobytes, and that is also like not a very high amount, and therefore we might not be able to work with large amounts of data in Arduino Uno boards or Arduino boards in general. So we need to work with large amounts of data. So for such applications, we have to use other kinds of boards. So when we talk about the Node MCU board, we have uh, the ESP 8266 microcontroller, uh, microcontroller module that is inside this hardware board is the ESP 8266 module, and that module is used to store the operating system and all the data and so on. So basically it is a ESP series microcontroller, and it also has kind of similar features to ESP32. However, there are some differences between this board and the ESP32 board. And this board is known as the Node MCU, and Node MCU has the ESP8266 microcontroller module, and its programming is done using Lua programming codes, and we can also use many libraries, and we can use many libraries to develop our code. So as I said before, the cost for this module, these microcontroller boards are considerably less than the Arduino and Raspberry. And when we talk about the connectivity, we can connect Wi-Fi to this board, right? We can connect through Wi-Fi, and we can therefore use internet, and we can do the rest of the IoT process. Apart from that, it also has the dual core functionality. That means there are two cores to do the processing. Therefore, we can achieve efficient processing in this board. So we will discuss about the ESP32 microcontroller next. And when we talk about this microcontroller, when we compare with the Node MCU, this microcontroller has, uh, you know, many uh, like many inputs than the Node MCU. So there likewise there are some differences between the Node MCU and the ESP32. And when we talk about the ESP32, I believe that ESP32 is much better in features than Node MCU. So one of the reasons is that, like, when we talk about the clock frequency in the ESP32 is higher than the a node MCU. The clock frequency of ESP32 is higher than the node MCU, and the clock frequency is in the range of in here it's in the range of 160 to 240 megahertz, and in here in the node MCU it's in the range of 80 megahertz. So the data processing speed is highly essential when we are doing IoT processes, and we want to send the data very quickly to our destination or to the cloud server. So we want like a highly efficient microprocessor, and therefore when we are talking about these two microcontrollers, we can say that ESP32 ESP32 module based microcontrollers are much more efficient than node MCU microcontroller boards. Then when we talk about the dual core functionality, in both the ESP32 and node MCU, we have the dual core functionality. So in both of them, we have two cores to do processing, and therefore is better than a single core processor. And both of them supports 32-bit dual core processing. So that means like at one time they can process 32 bits of data, and therefore is efficient than 8-bit processing, 8-bit processing in one instance. So therefore actually this dual core 32-bit processors are better than other 8-bit, for example, 8-bit processors out in the market. When we discuss about the other microcontrollers, when we think about the other microcontrollers which function with 8-bit single core, better than that, this 32-bit dual core is better. So 32-bit dual core has more functionality than the 8-bit single core microprocessors. And as we discussed multiple times before, ESP32 supports Wi-Fi, ESP32 supports Bluetooth, Bluetooth low energy, likewise, like communication technologies, and those technologies are inbuilt in the system itself. Sometimes these technologies might not be sufficient or sufficiently working, and in that time we need to maybe connect a separate external antenna or a Wi-Fi antenna to get the Wi-Fi signal properly into the ESP32 microcontroller board. So in such cases, we might need to go for external antennas. So although Bluetooth low energy, Wi-Fi, those communication modules are inbuilt, sometimes we need to add external, external modules to get the necessary signal strength for the connectivity to happen. So we might need to use some external modules to enable Bluetooth or Wi-Fi sometimes, depending on our scenario. If we cannot detect the signal properly, then we might need to add those, external antennas or modules. So by that, we can detect the signals properly through our hardware controller board, or our signals can be detected properly from our receiving end. So that is basically regarding the communication features. So then we will talk about the GPIO pin. So the general purpose, input output pins. So those general purpose input output pins are higher in the ESP32 when we compare with the node MCU. So there are more pins in ESP32. In ESP32, we have about 39 pins in total. We have about 39 pins in total, and in node MCU, we only have about 17 pins in total. So when we consider about the number of pins, that we are allowed to work with. ESP32 has more pins and therefore more analog and digital inputs into the system and more outputs from the system. Therefore, we can work with multiple sensors and uh, multiple other connective connections than the node MCU. So that is regarding the number of pins, and even in the number of pins, I think there's some advantage in the ESP32. Apart from that, in contrast to the node MCU, we have the Hall effect sensor in the ESP32. The ESP32, we have the Hall effect sensor that I mentioned in the last time. The Hall effect sensor is used to detect the magnetic field around us. Hall effect sensor is used to detect the magnetic field around us. And this Hall effect sensor is embedded in this ESP32 microcontroller, and it can measure the magnetic field around the environment using this Hall effect sensor inputs that the inputs that are obtained from the Hall effect sensor. We can detect whether there's some magnetic field. So that is also useful in some situations. So this is used for different applications related to the magnetic and electric field related, applications, right? So it can differ based on the application. So anyway, for such applications, we can use the Hall effect sensor in the ESP32, and from that output, we can decide whether there's some magnetic field around the ESP32 or not. And also there's an inbuilt temperature sensor in the ESP32. And likewise, we can see such features available in the ESP32. Apart from that, we also have touch pins, which are available in the ESP32 and which are not available in the node MCU. So in the node MCU, we do not have the touch pins feature. So in the touch pins, what is happening is that, like, once we connect a certain wire to these touch pins, and we are like giving some voltage or some kind of a once we touch the touch pin inputs, then we can see some output occurring in one of the pins in the hardware board. So these touch pins can be useful in situations where we need touch sensing application. Once we want to integrate some touch sensing touch sensing at the user level, then we can enable that using these touch pins in the ESP32. So therefore, I think this is a new addition or new feature in the ESP32, and which can be used for touch enabled applications. So applications that works with touch based or touch based applications, then I think we can use these touch pins for that. So we need to see where we can use this and use it such that we can develop a good product for the human interfaces. We can build a computer human computer interface using these touch pins. Another hardware controller board that we have is the Raspberry Pi that I mentioned before. I think Raspberry Pi is a very computationally efficient board. It is developed. Sorry. It is developed by this company that allows us to uh, do many applications, to do many activities using this Raspberry Pi board. The company has given resources in their website on how to install the necessary softwares and how to install and get the libraries functioning in the microcontroller board. So the only problem is its costliness. uh, so the amount of the cost of the board is a little bit expensive. It's little bit high than compared to other cheap microcontroller boards. However, there are instances that we cannot avoid using this Raspberry Pi due to its applications, especially in high computational costly tasks such as image processing, machine learning, and likewise and data management, likewise applications. So although Raspberry Pi is costly, people are using this board for many applications nowadays and testing those applications in these Raspberry Pi boards. Also, this can be extended for applications in the industry. So we will talk about the industrial applications of these microcontroller boards and how and where they are mostly used in a later instance. So we will discuss about the industrial IoT in a later instance. In that moment, I will explain to you and introduce you the specific hardware controller boards that are used in the industry. So now we are now talking about the household or office level microcontroller boards, which can be used for small tasks that are used for maybe short duration of time intervals. However, I will discuss with you under industrial IoT how we can use these kind of hardware boards and actually much enhanced hardware boards in industrial scenarios. Uh, then when we talk about the clock speed of the Raspberry Pi, we have higher clock speeds like 1.2 megahertz in the Raspberry Pi. And therefore we can do multiple computations. The one of the main advantages is having this 1 GB RAM, which allows us to store 1 GB of data in the RAM and allow us to upload large amounts of data at a certain time instance. Therefore, we can do multiple computations in the microcontroller board and enable us to get the data outputs. It also enables many interfaces such as HDMI, multiple USB ports, Ethernet ports, Wi-Fi port, Bluetooth, and many input-output pins. So it enables a lot of input ports and into this microcontroller board, and therefore we are able to work with different devices, and we can input data from those devices into this microcontroller board very easily. Also, it enables Wi-Fi and Bluetooth, and therefore we can use both these technologies, communication technologies, when we want to communicate with an access point and thereby a certain other device, or directly with another device, we can communicate using these communication technologies. Also, this Raspberry Pi supports Linux operating system and Python that enables us to develop applications very easily on top of this microcontroller module, because I think Linux operating system is much lightweight when compared to Windows and other operating systems, and therefore Linux is preferred for low computationally complex tasks. And Python is very easy to understand and very easy to deploy programming languages, and it is also used to develop any kind of application at the moment. So, and also it can also deploy machine learning models and such kind of algorithms. Therefore, Python is a very popular language today. So, since we are able to deploy Python in this operating system, then we can run Python scripts in this system. Then, therefore, we can easily get our algorithm working and algorithm implemented in the microcontroller board. So that's regarding the hardware controller boards. And those were the most popular hardware controller boards that I wanted to discuss with you about. So now I think I will share with you the attendance like QR code. So let me share it with you. If you have any questions, you can ask me. So please enter your, attendance into this system. And the OTP code is 8769. The verification code you can see as it changes. Right. I hope you provided your attendance. Right. Are there any more to give the attendance? I will close this, okay? Right. So now let's talk about the IoT protocols. So far actually, right? So far we discussed about the hardware components that we can use for IoT systems. So in the discussion so far, in the physical design of IoT, we discussed about the hardware components that are required for IoT implementation. Hardware components that are required for IoT implementations. And now we are going to talk about the IoT protocols. And IoT protocols are also essential when we are doing the hardware implementation of the IoT network. Or I can call it the physical implementation of the IoT network. So let's talk about the IoT protocols, right? So IoT protocols, in protocols in general, are a set of rules and guidelines that define how the data is sent or transmitted over the physical layer or the media. Okay, so in this scenario, protocol or IoT protocol. Uh, I mean, we are talking about the IoT protocols. IoT protocols define how the data is transmitted over the physical layer or the medium. So I think you must have learned about the OSI model in one of the earlier modules that you have learned about, right? OSI model that has 7 layers. However, in this course, under IoT protocols, we'll be discussing those IoT protocols under basically 5 layers. And even in that 5 layers, we will be kind of discussing about the physical layer and the data link layer protocols. I mean, in combination, because the physical layer and data link layer protocols work in combination with each other. So we will therefore discuss about those related protocols such as Zigbee, Bluetooth low energy, Wi-Fi, LoRa, NFC or near field communication, cellular, Z-Wave technologies. So the protocols that are used when we are using these technologies are known as the protocols related to these technologies. So the physical and data link layer protocols we will discuss first. And then secondly, we will discuss about the network layer protocols. The network layer protocols, we have multiple protocols. In this module, we will discuss mainly about the IPv4, IPv6, and 6LoWPAN protocols. So IPv4 protocol is the Internet IP addressing protocol, IP or Internet protocol based addressing protocol. So we can address devices or we can provide a unique address to each of the devices using IPv4 protocol. We also can give unique addresses to devices using IPv6 protocol. Then we will also discuss about the 6LoWPAN protocol, which is also a network layer protocol, which is used to do communication in the in specific scenarios. We will discuss about that in a later instance. In next, thirdly, we will have some transport layer protocols to discuss about. So TCP, UDP, these are the common protocols that are used for any other communication. So basically, transmission control protocol and the user datagram protocol. So the transmission control protocol and the user datagram protocol. So these are the popular protocols that are used in the transport layer. Next and finally, we will discuss about the application layer protocols and application layer protocols such as HTTP, MQTT, COAP, AMQP, XMPP. Discussed. So mainly we will discuss about HTTP, MQTT, COAP protocols, and then we will discuss about the AMQP, SMQP as well. However, we will focus on these protocols mainly, and we will discuss more about MQTT and COAP protocols, mainly because they are widely used in the IoT applications due to their special features in terms of low complexity and reliability. So we will discuss about that in the later instance once we reach to that stage. So basically, this is the IoT protocol stack, and these are the protocol layers. And the layers that correspond to the protocols, and the protocol examples are these examples. So we will start with the physical layer and data link layer protocols. So if you have any questions, please let me know. When we talk about the physical layer protocols, we have basically, protocols such as Bluetooth, Wi-Fi, and near-field communications, as I mentioned before. So these are mainly the communication-based protocols, that protocols that enable us to establish a communication between the embedded, microcontroller or the embedded system and the access point, right? So when we are doing IoT communications, we need to first establish the communication between the whatever the sensor-based embedded system and our access point. So when we want to uh, communicate with the access point, we need to use a specific communication technology, and we need to access the access point. So the access point could be a base station, it could be like a telecommunication tower, or we call this GNB in the 5G, or else it can be a router. Can be a router that receives the data. So it can be a router, can be a base station. So those kind of access points will be receiving the data from the sensor plus embedded system. So this sensor plus embedded system, which is a sensor node, will need to select the appropriate communication technology to communicate reliably with the receiver. So depending on the specific application, we need to select the type of communication technology that is used. So depending on the application, we can select the most suitable um, communication technology. So we need to know the features of each of these communication technologies in order to select the best option. So when we talk about the different communication technologies such as Bluetooth, Wi-Fi, and near field communication, for example, there are mainly three main parameters that we can consider that we can use to measure their performance. Right? So I will go back. So we can discuss about the communication range of the communication technology, right? We can now, when we talk about the communication technologies, when we talk about the communication technologies, we can consider the communication range. We can consider the communication range. We can consider the power consumption, right? So in IoT systems, since we will be remotely monitoring the system, we need to place the sensors in a in an area which is not accessible to us, and those sensors must be able to power up themselves in cases where the power supply is not present. And then we also can consider about the data rates that we can achieve. So we can consider about the communication range that we can achieve. We can consider about the power consumption of the communication technology, and we can also consider the data rates that we can reach using this communication technology. So we need to consider all these aspects when we are choosing the best communication technology for our application. Depending on the application, we need to choose the best one. So first of all, we will discuss about the Bluetooth energy and Bluetooth low energy protocol, which is Bluetooth low energy technology, and it uses the Bluetooth low energy protocol to communicate. So basically, Bluetooth low energy is a low power communication technology compared to the normal Bluetooth technology. And it is also a short range wireless protocol used commonly for consumer devices such as wearable devices, sensors, smart home devices, and so on. So basically, so in the Bluetooth module, we have several components. So we have the Bluetooth antenna, and then we will receive the Bluetooth signal through a certain frequency. So mainly it will be using 2.4 gigahertz frequency range signals, signals in the 2.4 gigahertz and around region. So based on the bandwidth, we can decide like what is the range of frequencies that this Bluetooth module is allowing. And then if we receive signals in that range, we obtain that signal, and then we control the whatever uh, the link, Bluetooth link, using the Bluetooth link controller. That means like this this controller can decide like when the message communication should happen and when it should stop, and what is the synchronous nature of receiving and sending data, and so on. And the communication link can be managed through the Bluetooth link manager. And afterwards, it can be also, received by the receiving end. So Bluetooth is one of the popular protocols that are used to connect devices in the IoT networks. So Bluetooth-based IoT is popular. However, one problem with the Bluetooth is having short-range communication, or the communication range is considerably short, and therefore it can only provide communication up to about 1 to 100 meters, about 1 to 100 meters. Even that uh, we can sometimes we might lose the signal strength. So therefore Bluetooth connectivity is above a certain above a certain level only within a very short range. Therefore we can connect devices at home to a certain Bluetooth device, such as, for example, like a music music box where we want to play the music and so on. But in the outer environment, in the field or something, when we are using Bluetooth, sometimes we might lose the connection with the devices that we are trying to connect with. So in that cases, we might need to select some other communication technology. Then we have the Wi-Fi, which is much more preferable in our day-to-day lives, mainly because of its data rate. It has higher data rates, and it has therefore it is more preferable and popular among the people when we compare with the Bluetooth. So data rates of the Wi-Fi is higher than the data rate of the Bluetooth. So therefore Bluetooth is less popular, or less, Wi-Fi is more popular than Bluetooth. So anyway, the Bluetooth is widely available currently in the world, and therefore there are many devices that function with Wi-Fi. So Wi-Fi is working under the protocol of 802.11 Wi-Fi protocol, or we call that 802.11 protocol, and it is a collection of communication protocols. There are many protocols that come under 802.11. So for example, we have 802.11a, which operates in the 5 gigahertz band. So basically it means that 802.11a is defined for a certain frequency range, and 802.11b and 802.11g operates in the 2.4 gigahertz range, and therefore those protocols are enabled only for this frequency range. Apart from that, there are like 802.11b and 802.11g. So what is the difference between these two protocols? So mainly like the amount of data rates that we can achieve between these two protocols, B and G, are different. Data rates are different. So data rates are different. And once the data rates are different, then based on our application, we prefer to use the one with the, I mean, one that satisfies our data rate requirement. So likewise, we have other protocol standards for Wi-Fi, such as 802.11n, which works both in 2.4 and 5 gigahertz range. And then 802.11 AC, which operates in both the 2.4 and 5 gigahertz. So the main difference that you might see in all these standards is that the data rates will differ in these different protocols, although they are under the 802.11 standard. The data rate that they can provide will differ. So likewise, some other features could also be affecting this protocol. So that needs to be referred before using this protocol. So likewise, now Wi-Fi has therefore, multiple opportunities, multiple options that Wi-Fi provides, and therefore it is widely used with the users. So we will also talk about the 2G, 3G, 4G mobile communications as well. So when we talk about the cellular communications, such as 2G, 3G, 4G communications, they are also very special because we use mobile communication for in our day-to-day lives, and we can achieve about 9.6 kilobits up to 100 megabits using the communication technologies with the cellular technology. So with 2G up to 4G, we can achieve up to about 100 megabits per second of data rates. So that is also one of the options for IoT communications. IoT, as it is also one of the possible communication technology for IoT applications. So therefore, there are many such communication technologies available. So I think I will stop with the cellular communications for today. So if you have any questions, you can ask. I think one student asked about what is the confirmation number for the attendance. I will share the screen again. Also, I have given you an assignment that you need to complete by this weekend, Friday, regarding the distance measurement error that you can observe in the ultrasonic sensor. I have uploaded the assignment in the LMS. So if possible, please complete it on time and submit. Try to submit it before the deadline. Okay. So if you have any other questions, you can ask. Otherwise, you can leave the meeting. So thank you so much for joining in for today's lecture. Also, if you have any questions, you can ask in the interactive class and you can get them all verified at that time. Okay. Hello, do you have any questions to ask? Hello, can you hear me? Okay, I will end the class if you're not having any questions. Thank you for joining.